Welcome to another episode of MrLopezClasses.com. We are going to continue in our marine transmission class. And this is the chapter 4. This is the episode number 2. And we are going to start to disassembly and to check internally the automatic transmission. And we are going to verify how that wonderful design, that magic design works. Yes, in the previous episode, we analyzed the torque converter. The hydraulic clutch is a magic element that engage, connect or disconnect the transmission and the engine with that hydraulic clutch. Of course, that procedure depends on the engine RPMs and depends on the load. Wonderful, I hope you enjoyed the previous video where I explained in details how the torque converter works, how the hydraulic clutch works, or wet clutch. Okay, this is the hydraulic clutch and those are the components. This is the torque converter. The torque converter is located inside of the bell housing because it's where the clutch is located. And after that we have in this area the oil pump. The oil pump, that's the element that circulates the oil internally, enter into the torque converter. You remember 3/4 of oil on the torque converter and return into the transmission. And after that we have a set of planetary gears and clutch packs. And today we are going to understand the meaning of the planetary gears and how the planetary gears multiply the torque and multiply the RPMs or reduce the RPMs. How the speeds are produced on the planetary gears. This is possible because of those planetary gears, the sun, the planets, and the ring, stop the sun and move the ring and stop the planets and move. That situation depends on a set of clutch pack and servo bands. We are going to explain what is the meaning of those clutch pack, those servo bands, in order to understand how can I stop the sun and rotate the ring, or stop the ring and rotate the planets. This is possible with a hydraulic fluid at high pressure and clutch packs and servo bands. This is in this section are located the planetary gears, how they are connected. I'm going to explain right now the clutch pack and the servo bands. And in the bottom in the oil pan, in the oil pump we have the valve body. That's the intelligent part of the system, the computer, and the filter, and the oil pan is similar to the engine. The oil pump, you remember in the engine we have the oil pan with the oil pump submerged over there. In this particular case the oil pump is here, but the oil pump suctions the oil from the oil pan, from the cavities of the housing of the transmission, suction the oil and compress the oil at high pressure and send the oil at high pressure to each planetary set in order to activate the clutch pack internally located in each set of planets. Yeah, right now we are going to analyze that situation. This is the transmission, and it's in my opinion the invention of the previous century. It's completely intelligent and every day is more sophisticated. The automatic transmissions every day are more and more sophisticated. I remember some years ago when the first automatic transmissions were introduced for General Motors, Cadillac, and Ford, and those transmissions were basically for differential of pressure, vacuum and positive pressure. Those differential of pressure, according with the acceleration, change the speeds, the gear ratios. But today is with solenoids. Those transmissions are fully intelligent. If you understand this transmission, after that the next coming transmissions, marine transmission inboard for gas and diesels, are too easy because you understand the clutch pack, you understand the servo bands, and how the fluid is moving internally in this transmission. Okay. We are going to start removing the torque converter, and after that immediately you remove the torque converter, we have access to the oil pump. And after that, we can start with the planetary sets and the closed pack and the servo bands and the rest of the transmission. Okay, in the next part of this video, we are going to analyze how the torque converter is removed. Hi guys, in this episode, we are going to explain the automatic transmission. The automotive transmission, automatic, and we are going to try to check what happened in the automatic transmission, how the closed pack work, how the planetary gears work, and how that intelligent transmission works. After that, you are ready to understand the marine transmissions, because the marine transmission is a perfect combination of both transmissions, manual and hydraulic transmissions. This is a perfect hydraulic transmission. Okay, as we explained before, the main difference between the manual transmission and the automatic transmission, there are a lot of difference, but the main difference is on the clutch. In the manual transmission, the clutch is a dry clutch, it's a mechanical clutch. Be careful because the people confuse. I have mechanical clutch with hydraulic clutch thrust bearing, but the clutch is mechanical. Remember that we have three types of thrust bearings in the mechanical clutch. Mechanical clutch with the fork, hydraulic with the hydraulic fluid, and electrical like a solenoid. But this is a mechanical clutch or dry clutch. In automatic transmission, we have a wet clutch. Wet clutch, that the name of that clutch is the torque converter. I explained before that the first step to remove the transmission and disassemble the transmission is disconnect the torque converter from the flywheel. The torque converter is bolted on the flywheel. When you remove the start motor, you have access to those bolts because the start motor is located here, and when you turn, the start motor is located here. When you remove the start motor, you have access to those bolts, and you can move it, the torque converter, and you can disconnect the flywheel because the flywheel is located here, and this is the torque converter. In this moment, I remove the bolts, and I am ready to remove the torque converter. It's important the O-rings that the torque converter have. In the moment that you remove the torque converter, you need to be careful with the oil because this torque converter is full of fluid. If you check over there, we have a lot of fluid coming out to the torque converter. Okay, and right now we are in front of the oil pump. This is the oil pump. We are going to remove those 4 bolts, and we are going to remove the oil pump. The oil pump have a bigger O-ring over there. As soon as you remove those bolts, the oil pump can be removed. And this is the typical oil pump, and this is the O-ring that keep the oil inside of the transmission. This is the O-ring that we are going to replace. As I explained before, the secret in the hydraulic transmission or automatic transmission is that all the shafts are hollow shafts. What is the meaning of that? All the shafts, they are one inside of the other one, like a telescopic situation. This is this particular situation. Remember when I explained the torque converter, that with the stator in the torque converter, the oil return into the transmission. This element enter over there, and the oil goes over there and return into the oil pan of the transmission. The oil circulate in between the pump and the turbine, push the turbine against the face of the housing of the torque converter, and the oil return into the transmission, into the oil pan. Okay, now you understand how the torque converter is removed. It's too simple. You need to be careful with the O-ring. You remember the orange ring that I showed on the video, correct? And with the oil, because that converter is full of oil. You need a place the torque converter in a properly way in order to avoid a spill hydraulic oil on the floor. Right, that's the torque converter, and right now we are going to analyze the oil pump, and we are going to remove the oil pump, separate the oil pump, and we are going to check internally the crescent, the gears of the oil pump. Alright, this is the oil pump. Now we are going to disassemble the oil pump. We remove the bolts, and now this is the last bolt, and we are ready to check the oil pump internally. And this is the oil pump. This is a crescent gear oil pump. That's the crescent, and that's the external ring. If you order the kits, you receive those gears. And this is the typical crescent oil pump. This is the input. This is the input, and this is the output, and this is the typical oil pump. Yep. This is the input and output, and this is the pressure regulator. The pressure regulator is installed over there. This is the input shaft of the transmission, and this is the disassembly of the oil pump. When the input shaft is engaged with the flywheel of the engine, because the turbine internally in the torque converter engaged, internally the oil pump compress the oil and send the oil at high pressure through those holes, and those holes introduce the oil in the cavities of the housing of the transmission at high pressure. One of those holes introduce the oil into the first set of planetary gears, and the other holes introduce the oil into the cavities of the housing of the transmission, and circulate for different functions, for clutch packs, for a set of planetary gears, for bands, solenoid to activate the bands. There are different elements that should be activated and lubricated with the oil coming from the oil pump. Perfect. This is exactly the situation that we have in our marine transmission. But if you check those previous videos, the life of the automatic transmission depends basically of the quality of the oil, and depend of the pressure of the oil, the pressure produced for the oil pump. Yeah, this is the vital component of the automatic transmission. This is a perfect schematic of the automatic transmission. We have here the torque converter, and after that we have the oil pump, and after that the set of planetary gears and the clutch packs, and in the bottom we have the valve body, and we have the computer and the filter, and the fluid return, because the oil pump suction the fluid again and return and return and return. This is basically the schematic of the automatic transmission. This picture, the second picture, this is another good schematic about the automatic transmission. Let me show what happened in this particular transmission. This is the torque converter, and the fluid is located in the bottom, and this is the oil pump. The oil pump suction the fluid, and the fluid enter. You remember the fluid because the stator introduced the fluid over there. The fluid passed in front of the turbine. Exactly, the fluid passed in front of the turbine and move the turbine against the face of the torque converter and engage the clutch. And the fluid after that return over there, and the fluid enter. This is the set of planetary gears. Those are the clutch packs, and those are the servo valves, and one portion of the fluid goes in, normally in automotive transmissions, goes into the radiator, and in the radiator the oil is cooled and returned with low temperature into the transmission. In your boat, the oil goes into the heat exchanger, oil cooler for heat exchanger, and the oil return again return again into the oil pan, and we have the filter here. Okay, this is basically a typical hydraulic schematic. This is a hydraulic schematic. In our next class of auxiliary systems, we are going to study hydraulic systems, and I am going to explain what is the meaning of this servo valve, how the servo valve works, and how the fluid is moving depending on the position of the plunger internally in the servo valve. But this is a good schematic about the transmission, and the same in the auxiliary system. I am going to try to explain the procedure to understand hydraulic schematic. A hydraulic schematic like this. This is not an spaghetti. It's a hydraulic schematic, and if you have the hydraulic schematic, it's the same like if you have the wiring diagram. You can solve it any type of problem. It's exactly the same. It's exactly the same configuration. We have the oil pump here, we have the torque converter over there, and we have the different servo valves for forward, for reverse, and the solenoid. This is the roadmap for the hydraulic system. If you follow the roadmap, it's easy to identify the problems and solve the problems. Yes, my friends, in automotive transmissions, the oil, the secret is keep the oil with a good viscosity and good temperature. For that reason, all the automatic transmissions, automotives, they have a radiator dedicated to reduce the temperature of the oil. In some engines, the radiator is common for engine oil and transmission in the bottom. Different compartments in the same frame. But one portion of that frame is for the automatic transmission, and the other portion for the engine oil, the motor oil. Yes, and the secret is keep the temperature as low as possible. If the temperature pass the limit, I'm going to explain later what is the limit, immediately the friction material on the friction disc is completely gone, is destroyed, and immediately the transmission is sleeping, and you have overheating, and the transmission is destroyed. The secret is the quality of the oil and the temperature. The temperature is a vital component. Okay, my friends. All right. In order to understand the hydraulic transmission, the automatic transmission, I want to refresh a concept that we learned in the previous transmission. Is the concept about the gear ratio. You remember? What is the meaning of gear ratio? In this particular case, I have a couple of gears together, one gear with 25 teeth and the other one with 75. Then the gear ratio is 3:1. This is the gear ratio of that compound, two gears together. But what is the secret in that particular case? One gear is rotating in opposite direction than the other one. Yeah, this one is rotating in this direction, and the other one is rotating in opposite direction because they are in permanent contact. And the gear ratio of this particular case is 3:1. That was the situation in the manual transmission. You remember, depending on the selector that you select different gear ratios in between the driver gear and the driving gear. And of course, the output shaft will be rotating at a high speed or low speed, high torque, low torque. In the automatic transmission is exactly the same, but that combination of gears is with the planetary systems. And today, right now, we are going to analyze the planetary system, how those gears work together in order to produce overdrive or underdrive in the output of the transmission. Okay, this is the typical situation in the previous transmission, in the manual transmission. And you remember how is the procedure in order to, I want that gear ratio 3:1, but I want that both of them rotate in the same direction, clockwise. In order to change the sense of rotation of the output gear, you need to introduce another gear in between, the idle gear in the middle. What is the meaning of that? The idle gear in the middle only change the sense of rotation of the second gear, but never modify the gear ratio. Like this. in this particular case. I have 25 in the first one, 75 in the big one. The gear ratio is 3:1, and the middle one no affect idle gear, no affect the gear ratio. Right now, both of them are rotating in the same direction. Both of them are clockwise. Wonderful. You remember that idle gear was introduced when you select reverse in the previous transmission, the manual transmission. Yes, if I wanted change the sense of rotation of the second gear, I introduced the idle gear. That's the function of the idle gear. And in this particular example, all the gears are externals, but I can connect the same configuration internal, like this. I have the input gear and the output gear, one inside of the other one, no externals, no like this. What is the advantage of the second of this option? In this option, I have all the shafts aligned. If one shaft is hollow and enter in the other one, and the other shaft is bigger and is hollow and enter, I have all the shafts one inside of the other one, like a telescopic. For that reason, the automatic transmission is like a funnel, because all the shafts are one inside of the other one. The shafts are hollows, and the fluid passes through the middle of those shafts. This is a great design. This is the principle of the planetary system, the planetary gear system. Yes, because in this particular case, I want the gear ratio in between this and this. Okay, I am going to stop the middle one. I want the output, the gear ratio in between this and this. I am going to stop the sun. Depending what gear ratio I wanted, I need to stop one of those gears, the ring, the planets, or the sun. Yes, the yellow one, this in the center is the sun. The blue ones are the planet, because in some cases you can design that system no with one gear, probably with 3 gears, other one here and other one over there, separated 120 degrees, and you have 3 gears. And this is a planetary system with 3 planets. There are planetary systems with 4 planets. What is the advantage? If you have more planets, it's more accurate, less sound, more precision. With 3, the sound is a little higher. With 2, is higher sound. But yes, you have a planetary system with 2 planets, the sun and the ring. Or with 3 planets, the sun and the ring. Or with 4 planets. Or 5 planets. Yeah, that's the design. Each manufacturer use 2, 3, or 4 planets normally. That's the common combination. Okay, we are going to start to analyze how can I increase the output torque or reduce the output torque. How can I increase the output RPMs or reduce the output RPMs with combination of those planets, sun, and gear. And this is basically the situation that we have in particular, the planetary gears. The basic planetary gear set consists of the sun gear, the ring gear, and 2 or 3 or 4 planets connected together. This is the perfect example. If you check the blue one, in this particular case is the sun, the planets are yellow ones, and the ring is orange. Yes, you can converge all of those elements in one central shaft. This is the perfect situation. We have the yellow shaft inside of the blue one, and all of them are hollow. The yellow one, the fluid in the yellow one can pass internally through this point. With respect to the last one, to the green one, we can install the shaft. We can design the shaft for the green one here, connected to the triangle, to the link, and this shaft, of course, will be hollow. In this particular case, we have 3 shafts completely aligned, or you can put all of those 3 shafts one inside of the other one. This is the magic secret of the automatic transmission. And of course, the fluid is passing internally. The fluid enter over there, and the fluid pass completely through the pipes, through the shafts of the planets, or the sun, or the rings. Okay, we are going to continue with the analysis of the planetary gears. This is the planetary gears are connected to each other through a common carrier. In this particular case is the yellow one. In my example is the green one. Okay, my friends, right now it's clear, and in this short video clip, I am going to explain the speeds, the gear ratios produced for the planetary gear set. The planetary gear is a set of gears: the sun, the planets, and the ring. Those elements can be combined together in this array. The sun, the planets are connected together, and the ring. Each set of planetary gears produce 2 gear ratios underdrive in forward, and 2 gear ratios overdrive in forward. Each couple of gear ratios, underdrive or overdrive, one is useful and the other one unuseful. Let me explain what is the meaning of that. What is the meaning of underdrive gear ratio? An underdrive gear ratio is because the output shaft turn is lower than the input shaft. This is underdrive. Typical example that the output shaft turn is lower but high torque than the input shaft. One of those gear ratios produced in underdrive is useful, first gear. The other one is less speed and a lot of torque. That's practically impossible. For that reason, one is useful, the other one is unusable. The same with overdrive gear ratios. What is the meaning of overdrive? Is that the output shaft is spinning faster than the input shaft. Yes. For example, 4 gear, 5 gear in a 5 speed transmissions, or 4 speed transmissions. What is the meaning of that? The output shaft turns faster than the input shaft. The gear ratio is 0.75 turns of the crankshaft produce 1 turn of the output shaft. Okay, this is overdrive. This is the most common. This is the most useful. Other one, 0.5 rotation of the crankshaft produce 1 rotation in the output shaft. Oh, that's too much. It is not useful. The other one, 0.2 rotation of the crankshaft produce 1 rotation. That's crazy. Those are crazy. Those are unuseful. This one is useful. The first one, 0.7 to 1. This is the most common for overdrive. In other words, in a typical planetary gears, we have 2 gear ratios for forward, 2 gear ratios for forward, and 1 gear ratio for reverse. 2 gear ratios for forward and 1 gear ratio for reverse. For that reason, in a typical automatic transmission, you have one set. Suppose that the transmission is 4 speeds, 4 speed in forwards. I have one planetary gears for two gear ratios, and other one in tandem for the other 2 gear ratios. That transmission internally have 2 sets of planetary gears because it's 4 speeds in forward, and in one of those is produced the reverse. And right now I am going to explain how is the process to produce first gear, second gear, direct drive. Direct is 1-to-1 when the transmission, the input shaft and the output shaft are spinning at the same speed, 1-to-1 direct, or overdrive like this. Yeah, I am going to explain right now how is the process to produce those gear ratios with those planetary gear set. How is that internally work the system to produce those gear ratios. Okay, this is the process to produce forward gear ratios and reverse gear ratios. That's wonderful. We have underdrive gear ratios and overdrive gear ratios. And yes, in each transmission, depending on the transmission, if the transmission is 4 speeds forward, we have 2 set of planetary gears connected in tandem. And if the transmission is 5 speed, probably you have 3 sets of planetary gears. Yeah, that's depend of the design, depend of the manufacturer. Now the secret is how can I stop one gear in order to produce forward or reverse. What is the process? In order to stop, in order to lock one gear and keep the other one free, we are going to use clutch packs, and also we are going to use servo bands. Now I am going to explain in a simple way how the clutch pack works. In this explanation is an explanation that I did for an inboard marine transmission for diesel engine, but it's the same. The concept of the clutch pack is used in different transmissions. This is the procedure, this is the way how the clutch pack works. This is the shaft with the clutch pack for forward. This is the input shaft. In this moment the input shaft, and this is the gear that engage with the gear of the output shaft with the coupling. This gear engage with this gear. In this moment, because fluid is not entering here, the input shaft is not engaged with the output shaft. The output shaft in this moment is stationary because I don't have pressure of fluid at the input. I don't have fluid entering at high pressure over there. When the fluid enter here, because this one is selected in forward, the body of valves, the fluid enter here, pass over there, and immediately enter in the clutch pack. In the clutch pack, I have a set of friction discs with stainless steel separated. I have friction plate, stainless steel plate, friction plate, stainless steel plate. I have like a 15 and 15 or 20 and 20 depending of the clutch pack. Those elements are located internally here. If you check those plates, the friction plates have the teeth internal, and the stainless steel plates, they have those teeth externals. In other words, I have one shaft connected internally with the friction discs, and I have other case connected externally with the stainless steel plates. For example, with this shaft are connected the friction discs, and with this gear are connected the stainless steel gears. In this moment, the friction discs and the stainless steels are free. Because we don't have fluid in between both of them at high pressure. When the fluid enter over there at high pressure, the fluid immediately connect both plates, and this shaft with this shaft are connected together. When the fluid enter at high pressure internally, close the discs, and this shaft are connected together immediately. In this moment, because I don't have fluid, this shaft rotates free with respect to this. This is the function of the closed pack. The closed pack, when the fluid enter and compress, connect this gear with this gear. This is the function of the closed pack. Okay, this is the closed pack. And the other one is the servo band. How the servo bands work. This one, the servo band. A band in steel with a friction material. Yes, my friend, the friction material is located over there. This is a ceramic material. This is the secret of the automatic transmission. Is the friction material. You remember in the closed pack that I explained a couple of minutes, the secret of the closed pack is the condition of those friction discs. If that material, that ceramic material, is gone, is eroded, normally because water enter in the transmission is gone. For that reason, the transmission should be hermetic, and the quality of the oil is the secret of the transmission. Yes, you need to replace that oil frequently. No, the service manual says that I never replace the oil. No, that's the business. That's the business. They want that you destroy the transmission each 3-4 years and replace for a new transmission. Remember that in the new automotives, the most expensive part is the transmission. In some cases, repair the transmission is too expensive. It's better buy a new car. Flush the oil each 1.5 years, maximum 2 years. Change the oil and change the filter. I'm going to explain the procedure. Alright, my friends, the friction material is the secret. This is the servo band. How the servo band works? Because we have a servo solenoid or an electrical solenoid. There are a different type of solenoid that close the band, and the band close, and you stop normally the ring. In the Planetary, the ring is locked with the servo band. And how the servo bands works is like this. Each set of Planetary gears produce different gear ratios in forward and reverse. This is possible because you need to stop the sun and rotate the planet and the ring, or stop the ring and rotate the planet and the sun, or stop this and this, or stop all of them. The process to stop one gear with respect to the other ones is by means of the closed pack or by means of the servo valve. For example, normally to stop the ring, this is the set of Planetary gears. This is the set of Planetary gears, and this set, the ring is here. This is the ring. I enter here into the ring, and the procedure to stop the ring, this element, is with the servo band. The servo band have friction material here, the same friction material used in the closed pack. You remember in the closed pack you have friction material, friction discs with the teeth internals, and stainless steel, friction material, stainless steel, friction material, stainless steel. In other words, the closed pack, one shaft is connected with the internal teeth of the friction material, and other shaft is connected with the teeth of the stainless steel plates. When the fluid enter at high pressure over there, compress the plates, and this shaft is engaged with this. This is the closed pack, you remember in the previous example. The servo band is the same friction material with a stainless steel band. And this element is externally on the ring. It's located externally on the ring. And this element is activated with a solenoid. The solenoid close or open, and you stop the ring or lose the ring. In other words, the servo band is activated for a solenoid in order to stop or lose, stop or free. This is the procedure with the servo band. And once again, the secret is the material, the friction material, and the quality of the oil. If the oil is a dirty oil, eroded the material, the friction material, the enemy of that friction material is the water. For that reason, you need periodically check the color of the transmission oil. Verify if the color become brown or if the color is milky. You need immediately flush the oil, replace the oil, and verify where is the intrusion of water in the transmission. The enemy of the transmission is the water. Okay, my friends. Now we understand the planetaries. We understand the clutch pack. We understand the servo band. And now we are going to analyze how to produce first gear and how to produce second gear, third gear, and reverse. Okay, we are going to follow those slides slowly, and we are going to analyze in each of those slides the situation. We are going to refresh the planetary gears. One example of a way that this system can be used is connecting the ring to the input shaft. Okay, my input shaft will be the ring, the external ring. Coming from the engine. Yeah, of course, this is the input shaft that is connected with the turbine, and the turbine engaged with the flywheel. All right, perfect. That's the input shaft coming from the engine. Connecting the planets to the output shaft. Okay, the carrier for the planets is connected in the output shaft. Input shaft is the ring, and the output shaft are the planets. And we are going to lock, we are going to stop the sun gear. In other words, the sun gear is fixed. And we are going to check what happened. How can I stop or how can I release some elements? Okay, in this particular example, I have this situation. This is the input shaft. This is the input shaft, and this is the output shaft, the yellow one. Let me analyze. The input shaft, according with our previous explanation, is the ring. Okay, this is the ring. Yes, okay. Yes, this is the ring. That's clear? That's the ring. The output shaft is the carrier of the planets. Okay, the output shaft is the green. That one. This is the output shaft. Okay, the output shaft, the green, is connected with this planet, and is connected with this planet. Okay. Alright. The green is the carrier of the planets and is the output shaft. And the input shaft is the ring. Good. And what about the sun? The sun is located in the middle. The sun is located here in the middle, is this one, and is the yellow one. And the shaft of the yellow one is this one. Okay. I have three shafts. The yellow shaft, I have the blue shaft, input for the ring, and I have the output shaft, the green. And now I am going to try to play. I am going to stop one, I am going to stop the other one, I am going to move the ring, I am going to create different combinations. Let me explain something. We are going to analyze how can I put together the planets and the sun. Let me check. The sun is the yellow one, is this one, the yellow one. And the planets are the greens, this one, the greens. Look at this. The planets have, for example, the stainless steel plates. And the sun have the friction material over there. And I have the fluid here coming from the oil pump. That's the oil pump. And this is the reservoir of the oil. And I have the gears here. This is the oil pump. And the oil enter, suction over there, is compressed and sent at high pressure. When the oil enter at high pressure here, this is the closed pack. That closed pack close, and now the planets and the sun are together. Oh, wonderful. And the ring is free. Wow. In other words, in this particular example, I lock the sun and the planets with a closed pack. And how can I lock? How can I stop the ring? With a servo band. In this particular case, I want to stop only the sun, not together with the planets. I want to stop only the sun. I am going to use this servo band, and the servo band lock only the sun. Yes, you have different combinations, and right now we are going to play with those combinations. Okay, we have the planets, the planetary gears connected in this way, and we are going to analyze. The input shaft is connected to the ring, the blue one. The output shaft will be connected to the planets, the green, and the green have the closed pack. You remember I explained before, and the sun will be the yellow one. Okay. The sun gear is connected to the drum, the yellow one, that is also connected to the other half of the closed pack. I explained before, the closed pack is composed for disks in between the sun and the planets. Okay, surrounding the outside of the drum, and the drum is connected with the sun, is the red band. This is used only to lock the sun. That can be tied around the drum when it's necessary to stop the sun. Perfect. Okay, and this is the picture. This is exactly the picture that I explained before, and right now we are ready to start to analyze first gear, second gear, reverse. Alright, first gear. We are going to check how can we produce the first gear. In this scenario, when we turn the ring gear, when the input shaft is on the ring, the planets will walk along the sun, and the sun is stationary. The sun is stopped, producing the planet carrier to turn the output shaft in the same direction as the input shaft, but at a little slower. You remember what happened when the output shaft is spinning a little slower than the input shaft? You have underdrive gear ratio. This is the first gear. Once again, I'm going to repeat. In this scenario, the input is on the ring. The planets will walk along the sun. The sun is stationary, producing that the planet carrier turn the output shaft in the same direction that the input shaft, but slower, producing a gear reduction, underdrive. This is the first gear. Let me analyze that situation. Is this, once again, the input is on the ring. The input is on the ring. For that reason, I put here on the ring 7 RPMs. And the sun is stopped, is 0. And we are going to analyze what happened with the planets, the carrier. This is the output shaft. Nice. This is the situation. This is the situation that we have. The sun is locked, is stopped, is not moving. If you check the sun here, the red one, is not moving. And the output shaft are the planets. The output shaft is spinning slower than the ring. This is first gear. And what is the gear ratio? The gear ratio in this particular case is the ratio in between the gear of the planet and the gear of the ring. This is the maximum gear ratio. For that reason, it's underdrive, and this is the first gear. You like it? That's wonderful. And what I did, I lock the sun. I put the input on the ring and the output on the planets. And I produce underdrive gear ratio. In other words, the output shaft is spinning slower than the input shaft, but with high torque. This is the typical first gear. Okay, wonderful. We are going to check another one. For example, the second gear or third gear is because in the sun, the gear of the sun is long, and you can accommodate with the same sun different combination of planets and rings, and you can produce other gears. Let me analyze this one. High gear. We are going to analyze high gear. If we unlock the sun, right now the sun is free, and lock any two elements together, this will cause all three elements turn at the same speed. This is 1-to-1. This is direct drive. You remember in the manual transmission you have 1, 2, 3, 4, and D direct. It's because the input shaft and the output shaft are spinning at the same RPMs. This is the maximum. This is 1-to-1. This is direct drive or high gear. Let me refresh. We are going to unlock the sun. Right now the sun is free, but we are going to lock any two elements together, the planets and the ring. This situation causes all three elements turn at the same speed, so that the output shaft will turn at the same speed that the input shaft. This is in your car. If the transmission is 4-speed, is the 4-speed, or 3-speed, the 3rd-speed, the high gear. Okay, let me analyze what happened in this situation. Once again, right now the sun is free. I put A RPMs in the sun. The ring and the carriers are in zero. Both of them are in the middle, in zero. They are locked. How can I lock two together? With a clutch pack. And the sun is free. Remember that the sun is with a band. Okay, right now the sun is free. And let me check what happened in this particular case. In this particular case, look at this. All the shafts are spinning at the same speed. What speed? The speed of the sun in this particular case, 8 RPMs. All of them are spinning at the same speed. This is direct drive. You like it? That's wonderful. Okay, my friends, we are going to play with another one. We are going to check here reverse. We are going to check reverse. Another way that we can use the planetary gear is for reverse. We are going to lock the planet. Right now the planets are stopped. The green shaft is stopped. We are going to apply input power on the ring, and the sun will be rotating opposite, in reverse. Once again, I am going to stop the planets, lock the planets, and right now the input is on the ring, and the output, the sun, will be rotating in opposite direction. And I have the gear ratio in between the sun and the ring, high gear ratio. But the sun is spinning in opposite direction. This is reverse. Nice. Let me check that situation. Yes, the sun, the planets are locked, zero RPMs, and we are going to check what happened in this particular case. The planetary carrier stopped. The input is on the ring. I put 8 RPMs on the ring, and of course the sun will be spinning, but in opposite direction. Let me check. Okay. Oh yes, the planets are stopped. The planets move a little because the momentum of the system, but it's nothing. If you remove the gas pedal, it's moving a little, practically nothing. Yeah, that's the movement. We consider the planets stop. But look at this. The ring, and the sun are spinning in opposite direction. The input is the ring, and the output is the sun. And this is reverse. Yes, my friend. This is the secret of the automatic transmission. It's too simple, it's not complicated. This is the way that the automatic transmission works.